In this video, we will talk about how to determine where a function is increasing, decreasing, or constant. So I have three examples for us to work through here. Let's check out this first one. Let's say we have this graph right here that represents a function, and we want to know where is this function increasing, decreasing, or constant. So the way that we solve these types of problems is we first work our way from the left side of the graph to the right. And we just ask ourselves, as we move from left to right, what are the y values in the graph doing? Well, we can see as we're getting further and further to the right, these y values are starting to decrease. They're getting lower and lower and lower until we reach this point right here, and that's where they start to increase again. If we imagine that this arrow over here just extends on and on, it's extending towards negative infinity all the way out here. So we could say that from negative infinity all the way up to the x value of 1, 2, 3 right here, from negative infinity up to 3, the graph is decreasing. So as we're moving from left to right, the graph is decreasing. So for the decreasing interval, here's what we can write. Negative infinity, and we'll write this in interval notation where we use an open parentheses because we can never actually touch the point negative infinity. And we go all the way up to the point of, we said x is 3 right here. So from negative infinity up to 3, the graph is decreasing. The y values are getting smaller. And we also use an open parentheses on 3 because at the point 3, this is just the turning point where it goes from increasing to decreasing. So we'd say 3 is not included in the decreasing portion. And then what we'll notice is starting from the x value of 3, as we keep moving to the right towards infinity, now the graph is starting to increase. The y values are getting larger. So we would say it's increasing from 3, again in open parentheses because 3 is not included, all the way to positive infinity. The y values are increasing. Now for this one, the graph is not constant at any point, so we won't have any interval here. So this will be our final answer for this one. All right, let's try another example. Let's say we have this graph right here, and we want to know where is it increasing, decreasing, and constant. So if we start again on the far left side of the graph and we work our way to the right, this far left side, we can see that this arrow extends towards negative infinity. So as we work our way to the right, we can see that what are the y values doing? Well, they're getting larger and larger and larger. They're increasing until we hit this point right here, which is an x value of -1. So what we can say is the graph is increasing from negative infinity all the way up to an x value of -1. So we'll say negative infinity, comma, -1. Now what we'll notice is that from an x value of -1 to +1, so this line right here, the graph is constant. So what we can say is that the graph is constant from an x value of -1 to +1. So we'll write -1 to +1. And then lastly, we can see that when the graph hits a +1, when we keep moving to the right, so we're going all the way to positive infinity over here, from an x value of 1 to positive infinity, the graph is increasing. The y values are getting larger again. So for this one, we already have one interval for increasing. We can union that, so a u, with the interval 1 to positive infinity, because that's where the graph is also increasing. So we have two intervals where the graph is increasing, and in this particular example, there are no intervals where the graph is decreasing. All right, let's try another example. Let's say we have this graph right here, and we want to know where it's increasing, decreasing, and constant. So once again, we'll move from left to the right, and we'll see what the y values are doing in the graph. So we can see this arrow right here extends all the way over here, and it just keeps going and going towards negative infinity. So from negative infinity all the way up to, it looks like this point right here, we can see that the y values are going down. They're decreasing until we hit this point right here, which looks like an x value of -2. So from negative infinity to -2, as we're moving from left to right, the graph is decreasing. So we can write for the decreasing negative infinity to an x value of -2, we're decreasing. Now once we hit an x value of -2 and we keep moving to the right, we can see that the y values start to increase until right about here. So from -2 to this is an x value of 0. So from -2 to 0, the graph is increasing. So we'll write -2 to 0, the graph is increasing. And once we hit this x value of 0 and we continue to move to the right, we can see that now the graph starts to decrease. So it's going down, the y values are going down again as we move all the way to positive infinity over here. So we'd say it's decreasing from 0 to infinity. So again, for the decreasing, there's another interval. So we'll union that, and we'll say from 0 to positive infinity, we're decreasing. So for this example, we have two intervals where we're decreasing, and there are no intervals where the graph is constant. So those were just a few different examples of how to determine where a function is increasing, decreasing, or constant.